Hello everyone, my name is JJ, and my project is titled Predicting the Late Deliveries for the Critical Project Materials in Infrastructure Project using the material machine learning. The infrastructure project depends on the timely delivery of the critical materials such as the electrical equipment, building management system, and automation components. When these materials arrive late, the project may experience the schedule delays, increase costs, and reduce the customer satisfaction. The goal of this project is to develop a machine learning solution that predicts potential delivery delays before they occur, allowing the project and procurement team to take the proactive action. Next is the opportunity evaluation. I selected this problem because this is an attractive opportunity for the machine learning solution based on three key criteria. First, the problem have a significant business impact. The delivery delays can directly affecting the project schedule and the profitability. Second, there is a large amount of the historical data available, including the supplier performance, lead times, shipment records, and the procurement information. Third is the prediction are actionable. If the delay are predictable, the teams can expedite the shipment, adjust their schedules, or identify the alternative suppliers. Since the problem have a business value, available data, and the actionable outcomes, it is well suited for the machine learning. Next is the business understanding. The business objective is to reduce the project delays caused by the late supplier deliveries. The machine learning objective is to build a supervised learning classification model that predicts whether the purchase order is likely to be delivered on time or delay. The success can be measured using both outcome metrics and the output metrics. The outcome metrics are the on-time delivery rate and the project schedule adherence, which reflect the business performance. The output metrics are the recall, precision, and the F1 score. The recall is particularly important because failing to identify a delayed shipment could lead to the project disruption. The potential factors influencing the delivery performance, including the supplier history, lead times, material category, shipment method, supplier location, weather condition, and the project priority. Next is a solution validation plan. The proposed solution is machine learning model that generate a delay risk score for each purchase order. To validate the concept, I will first interview the procurement managers and the project managers to understand both their current challenges and determine whether the predictive insights could improve the decision making. Next, I would develop a simple dashboard which displaying the delay risk score and test it using the historical procurement data. The solution then could be pilot using a small group of the users, and the feedback could be collect regarding of the usability, accuracy, and business value. Lastly, based on the feedback, the solution would be refined through the multiple iteration before the wider deployment. Next is the machine learning system design. The system would use the supervised learning because historical data contains known outcome indicating that whether the deliveries were on time or delay. I select the online prediction because the shipment information change continuously. The new updates from the suppliers and the logistic service provider should trigger the updated prediction in a real time. The system would also incorporate into the human in the loop approach. The procurement professional would remain responsible for the final decision, while the model would provide the recommendation and the risk score. Lastly, the overall architecture consists of the data flowing from the ERP and the logistic system into the centralized database, where the machine learning model generates the prediction that are displayed through the dashboard. Next is the potential risk in the production. There are several risks may affect the model performance in the production. Data drift may occur if the sourcing strategy change, new suppliers are introduced, or the transportation method evolve. The concept drift may occur if, let's say, the supplier performance change due to the economic condition, geopolitical events, labor shortage, or the logistic disruption. The training serving school could arise if the live operational data differs from the historical training data. The data quality issues such as the missing shipment updates or the incorrect delivery dates also impacting the prediction accuracy. To address this risk, the model performance should be monitored continuously and the model should be retrained regularly using the recent data. In the conclusion, predicting the late deliveries for the critical project material is a variable machine learning application that can help the organization reduce the project delays and improve the supply chain reliability. By combining the historical procurement and logistic data using the machine learning techniques, organization can identify a risk earlier and make the informed decision. Thank you.